All right, so this section is called special right triangles. So we have two different special right triangles. We have triangles that one of them is called a 45, 45, 90 triangle. That's when you have two angles that are 45 and one that's 90. And then we also have 30, 60, 90 triangles. They're special because that's their angle measures. Right? 30, 60, 90, and 45, 45, 90. There's certain patterns that we see when we have these types of triangles. So what we want to do is we want to discover these patterns so we can be real quick with these types of triangles. So in order to instead of just giving you, this is the pattern, let's discover it. So it says, first, fill in the missing angles in the square below, and then let's find the value of D in this square and simplify the radical. Okay, so I know all the corners are 90, so this is 90, that's 90. And then if you look, this is broken into two congruent angles. So if I wanted to break 90 into two congruent angles, that's 45 and 45. 45 and 45. So if I wanted to solve for D, I'm going to look at this triangle right here. I have two sides and I'm missing one side. I can use the Pythagorean theorem to solve it. Okay, notice that these two sides are exactly the same. They're both 5 and 5. Okay, so let's solve for D. Leg squared plus leg squared equals hypotenuse squared. 5 squared plus 5 squared equals D squared. So that is 25 plus 25 equals D squared. 50 equals D squared. Square root to solve. Now, usually we do plus or minus, plus or minus. We can still do that. D equals plus or minus, and then the square root of 50 is simplifiable, okay? So root 50, what's the biggest perfect square that goes in there? I'm going to list my perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 49, 64. All right, so I already passed 50. 49 doesn't go in there. 36 doesn't, 25 does. So I'm going to say root 25 goes in there twice. The square root of 25 is 5. So this is plus or minus 5 root 2. Now the diagonal is a length. So the diagonal cannot be negative 5 root 2. It's just positive 5 root 2. Okay. All right, so let's try another one. We're going to do the same thing. This is 45. This is 45. These two I know are the same. So we're going to do 2 squared plus 2 squared is equal to D squared. 4 plus 4 equals D squared. 8 equals D squared. Square root plus or minus, square root plus or minus. D equals plus or minus. And then any perfect squares that go into 8. I can look back up at that list that I made. Let me do a different color here. 8 falls right here. So I don't have to worry about any of these. 4 goes in there. So I'm going to say, okay, well, 4 goes into 8 how many times? Twice. And I know the square root of 4 is 2. So D is plus or minus 2 root 2. But remember, it's a diagonal, it's a length. So it's just 2 root 2. All right, so we've done 2. Should we do 200 more of these, or did we recognize the pattern? This is a 45, 45, 90 triangle. These two sides are the same, 5 and 5, and they're across from the 45-degree angles. The one across, the side across from the hypotenuse was 5 root 2. 5, 5, 5 root 2. This one is 2, 2, and this was 2 root 2. So do you notice the pattern? Hopefully so. In a 45, 45, 90 triangle, the two legs, if they have a measure of W, then the hypotenuse is just W root 2. So first off, I know this is a 45, 45, 90 triangle because these two sides are the same. That means these two angles have to be the same. So this is 45 and 45. Across from each 45, I can say that this side's W and W. And then this is root 2 times that amount. So whatever that number is, root 2. So if it's 6, 6, 6 root 2. 5, 5, 5 root 2. 10, 10, 10 root 2. So let's see how we do with 4 examples. Okay, so it says practice labeling the angles and the sides of the 45, 45, 90 triangles. So first off, I'm telling you that they're all 45, 45, 90. So the first thing that we can do is that we can go through and say this is 45, this is 45 degrees, and these two are congruent. This is 45, 45 degrees, and these two sides are congruent. 45, 45, two congruent sides. 45, 45, two congruent sides. Now, why was I able to do that? Because it says so right here. All right, now I'm going to find the sides because I found all the angles. That was easy, right? It tells me that the hypotenuse is 3 root 2. If the hypotenuse is 3 root 2, what are the legs? 3 and 3. 3, 3, 3 root 2. See that? Not so bad, right? Legs. The leg is 7, so both of them are 7. 7, 7, 7 root 2. A leg here, 3 root 2. 3 root 2, 3 root 2. And then remember, it's this number, this number, this number, root 2. This number, this number, this number, root 2. So this is 3 root 2, root 2. Now we can fix that up because that is hideous looking. We can multiply root 2 times root 2. Root 2 times root 2 is root 4, and root 4 is 2. So really it's 3 times 2, which is 6. Let's try another one that's not as hard. I don't think that's very hard, but at the same time, like, let's try one that's a little bit more difficult. We'll get to another one like that. Okay, one that's a little easier, I should say. Hypotenuse, 7 root 2. What does that make the legs? 7 and 7, right? Because it's this root 2. This root 2. See that? Okay. Now let's explore a 30, 60, 90 triangle. So it says draw an equilateral triangle. So I'm going to draw an equilateral triangle. There we go. That's the best I can do. So equilateral has 3 congruent sides. It also has 3 congruent angles. So I know this is 60 degrees, this is 60 degrees, and this is 60 degrees. Okay. What do we know about the angles? They're all 60, right? I already drew that in. All 60 degrees. If we take an altitude and drop it, what would that do to the bottom length of the top and the top angle? So let's take a different color here. We're going to go to the top, and we're going to drop an altitude. Okay, so what did that do to the angle up top? It broke it into 2 congruent angles. So instead of labeling that 60, I'm going to label it 30 and 30. And what about down here? These are perpendicular. That's 90 degrees. So if I trace this right here, okay, that's a 30, 60, 90 triangle. This is 30, 60, 90. So now we can see that the bottom length is half the size of the hypotenuse. So I kind of get ahead of that myself right here. If you look, this right here is the same as this right here, but we broke it in half. So if this is 10, this is 5. See that? Okay. If this is 7, this is 3.5, this part right here. Okay. So if this is x, this is half of x divided by 2. Right? Or 1/2 of x, or 0.5 times x. So let's try a couple problems to see if we can see a pattern like we did 45, 45, 90. Let's use the Pythagorean theorem to solve for the altitude. So if you look, I already filled this in. We have this side length was 8, and then this was half of that, which was 4. Okay, so let's see if we can see the pattern using Pythagorean theorems. We're going to do x squared plus 4 squared equals 8 squared. X squared plus 16 equals 64. Subtract 16 from both sides. X squared is equal to 48. Square root plus or minus. Square root plus or minus. I need to know the biggest perfect square that goes into 48. So my perfect squares I'll list right here. 4, 9, 16, 25, 36, 49. I passed 48. So I'll switch colors here. 36 doesn't go in there. 25 doesn't. 16 does. So this is going to be root 16. How many times does it go in there? 3. Root square root of 16 is 4. So I have x equals plus or minus 4 root 3. But remember, it's a length, so it's the positive 4 root 3. Okay. All right. Let's try another one because I see, okay, this is now 4 root 3. So I have 4, 8, and 4 root 3. Let's see if we can figure out a pattern if we have one more example. So we're going to do x squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. Subtract 25 from both sides. X squared equals 75. Square root. I know that I should be doing plus or minus every single time, but I know that I'm only going to get a positive answer. So let's just write down our positive answer right away. Biggest perfect square that goes into 75. So let's look. I gotta keep going. 7 squared, 8 squared, 9 squared. Okay, it's not that because it's too high. 64 does not go into 75. 49 does not. 36 does not, but 25 does. So 25 goes in there 3 times. So I have x equals, the square root of 25 is 5 root 3. 5 root 3. Okay, so let's see if we notice a pattern. 4 root 3, 8. 5 root 3, 10. Do we notice a pattern? So let's first talk about which side's the shortest. Across from the 30 is always the shortest side, and that's 5 and 4 in this case. If you look across from the 60, it's root 3 times that amount. Root 3 times that amount. If you look across from the right angle, it's double that amount. Okay? So across from your 30-degree angle is our W side. Across from 60 is root 3 times that, so W root 3. And across from 90 is twice whatever across from the 30 was. So across from 30, right here, W. Across from 60, W times root 3. Across from 90, 2 times whatever W is. Okay, so here I have some mixed practice. It's not just 30, 60, it's 45, 45, 90 also. And let's see what we can do here. Find the missing sides, and we should probably fill in the missing angles of each triangle. So we'll start with number 1. So I know this angle's 30. That means this angle's 60, right? So far that's done. Great. Okay, across from 30 is my smallest side. Across from 60 is root 3 times that, so 12 root 3. Across from 90 is double that small side, so 24. That one wasn't that bad, right? All right, we have a 45, 45, 90 triangle. Okay. So I was given across from the 45 is 10. That means across from this 45 is also 10. And then across from 90, remember that's our root 2 side. So that's 10 root 2. 30, 60, 90. All right, this time I was given my biggest side is 18. I know my smallest side is half of that. So across from 30 is 9. And then across from 60 is root 3 times my smallest side, so 9 root 3. All right, this is a 45, 45, 90 triangle. I know these two are the same. And I look and I see that that is root 98. Root 98 is not helpful because I'm looking for something root 2. So what I need to do is I need to simplify this radical. I need to know the biggest perfect square, and I want to know how many times it goes in there. Now, I want it to be something root 2, so I could start by saying what goes in there 2 times. 49 does. So this is actually, I can cross it off and change it to 7 root 2. Those are equivalent. So if the hypotenuse is 7 root 2, I know the legs are 7 and 7. Let's try this one. 45, 45. These two are the same, so 12 and 12. This is 12 root 2. Last one, this is 60, 30, 90. All right, once again, this root 48 is not very helpful. I know it's across from my 60, so I want it to be a root 3 side. So I can say, okay, what perfect square goes in there 3 times? 16 goes in there 3 times. So this I can cross off and change to 4 root 3. All right, so that side is 4 root 3. That means across from my 30, my small side is 4. and across from my 90, which is my